Hey, it's Mr. Hayashi with Geometry 2.5, proofs about segments and angles. And then, yes, I am wearing the exact same thing that I was yesterday for 2.4. I'm just kidding. I'm making both these videos in the same day. But a big part of geometry is proofs. So with proofs, a proof is just a logical argument, specifically using either facts, definitions, or specific properties to prove something's true. So by logical argument, things do need to be in a specific order. So again, every proof you'll be using either definitions, facts, or properties, like the properties of equality that we went over, to prove something's true. In geometry, many times, we'll prove theorems. I know we haven't specifically defined theorems in class yet. I know we've talked about them. A theorem is a statement that can be proven true, different than a postulate. A postulate is a statement that's taken to be true. It's taken to be true. There's many different types of proofs that we'll talk about and go over. Okay, the main type of proof that's like the most common or that we'll study the most extensively is a two-column proof, similar to the algebraic reasoning that you did yesterday or the last couple of days. When you made your algebraic equations, all the steps were on one side of your paper or in one column. All the justifications or reasons were on the other side of your paper or in a second column. That's basically a two-column proof. You make your two columns. Whatever type of proof you have, it's pretty obvious, in my opinion, why it's called that type of proof. For example, a paragraph proof, even though I'm not writing that down right now, would involve writing a paragraph. A flow proof or a flowchart proof would involve creating a flow chart, okay, if you're familiar with those. Or an indirect proof or a proof using indirect reasoning definitely uses indirect reasoning. Okay, but right now, the only thing I'm going to write down as far as a type of proof, even though I just mentioned a bunch of other types of proofs, are two-column proofs, because that's what we'll start with and that's what we'll mostly concentrate on. So with your two-column proof, it's called a two-column proof for a reason. You definitely have to have your two columns, but every two-column proof, no matter what you're trying to prove, there's a basic format. There's something that's given. What's given is going to be different every time. So I'm just going to write like something given, squiggly line or underline. There's definitely something that you always have to prove. That's why it's a two-column proof, because you're proving something. Again, that's going to vary from proof to proof. Usually you're given some sort of diagram as well to go along with your proof. And then to prove whatever you're trying to prove, kind of like with your algebraic reasonings, you'll have certain steps or statements. So you're making your two columns, or we break up our two columns like in a T-table usually. That's what I just made here. You have your statements or your steps here. You could label it either. And then you have your reasons or your justifications. You have to justify everything or give a reason for everything, just like you had to do with your algebraic justifications. So your steps, you usually number them. Not usually, you do number them. And then you number the corresponding reason. The first reason should correspond with the first step or the first statement. Second reason should correspond with the second step, and so on. So the number of steps and the number of reasons always has to be the same number. Like you can't have 5 steps and then only 3 reasons. Well, it might be the case that you're using the same reason more than once, but the number of steps you have, because you have to number them out, should be the number of reasons you have as well. You can't have more or less of either. And then whatever number you have for the steps, like I said, let's just say this is your last step. I'm going to call it X. That's the number. Then you should have that number of reasons as well. It's not going to be the same every time. That's why I let it be a variable. Could be 5, could be 3, could be 12, depending on the difficulty of your proof. In this class, we probably won't go over anything that's double digits as far as the number of steps and reasons. But your first step is almost always what is given. Then your first reason would be given. It's kind of like when you're writing your algebraic reasoning, the first step that you wrote down is whatever the given equation was. And then your first reason or justification should have been writing down the given equation. The last step should always be whatever you're trying to prove. So whatever this is, like prove angle A is congruent to angle B would be an example. But whatever you're trying to prove is what your last step should be, because once you've shown that that's true, then basically you're done with the proof. And then unlike the first step in reason, the last reason, it's going to be different for almost every single proof. The first reason for every single proof would be given. Last reason, it's just whatever you're using to prove whatever you're trying to prove. So unlike the first reason, I'm not going to write anything down. That's your basic format that you would follow basically for every 2-column proof.